Alrighty then, and welcome everybody to the Daily Space Weather. We've got a rather sudden intensification of solar activity here. Filaments being ejected. We caught a coronal mass ejection. Lots of stuff to cover. This filament here in the northeastern limb moving closer and closer to Earth here with solar rotation. Coronal mass ejection on the far side of the sun. And I saw no less than 4 sunspot groups when I did show prep. So 4 beta class sunspot groups, including this largest one. That's 2858 down there at the bottom of the screen. Here's some more imagery of this same area. That was 304 and 171 angstroms. This is 211 and 193 angstroms. Well-defined North Pole-oriented coronal hole ahead of that filament. And you've been seeing probably all over the internet stories about solar tornadoes. Oh my God, solar tornadoes, folks. It's not really anything like a tornado. Let's show you the coronal mass ejection. So coming out here to Lagrangian point 5 to take a look at the viewpoint from stereo A, the spacecraft that sees space weather before Earth, it gives us an idea of coronal mass ejections that are Earth-facing. This one's not at all. You can see it's a pretty high speed ejection here. It looks like maybe a little missing data there. It's on the far side of the sun. Just to reiterate, the Earth would be off in this direction from this perspective. Again, stereo A located at Lagrangian point 5 as it chases Earth orbitally speaking. And for you new viewers out there, we forecast coronal mass ejections in this area, not in this area. That's the non-Earth facing side. And when you see CME watch on our thumbnails, it's an indication that we are forecasting a coronal mass ejection. So here's the SDO animation, the Solar Dynamics Observatory animation of the solar magnetogram. It's showing you North Pole orientation in green, South Pole orientation in yellow and red, green and blue for North Pole. And I saw no less than 4 sunspot groups when I did show prep. So there was a beta class group here, a beta class group here, here. Actually here. And there was one down here as well. So a significant uptick here in solar activity. We're expecting a major increase in the X-ray flux here. Solar flare likelihood went up significantly with that. Radio flux currently up to 75. Still very low levels considering how far into the solar cycle 25 we are. Here's the 1-year chart of the radio flux over the past year from Solon.info. The black line's the radio flux. Red line is the sunspot number, and you can expect to see this come way up soon with all of those groups, especially if they increase in size, gain additional umbrae, etc. Here's a space weather enthusiast dashboard forecasting no space weather storms. I would expect a little higher KP index maybe starting August 20th. And into the 22nd. No major argument there, though. There are some coronal hole wind streams on the way, and I think we just saw another intensification. Speaking of which, there's been an intensification in earthquakes in the past about 3 weeks. This 90-day chart, you can look it up yourself at volcanodiscovery.com. South Sandwich Islands region still seeing an extremely high number of quakes. Some crazy shifting going on around down there near the Antarctic / South Atlantic / South Pacific tri-plate boundary. By the way, we've recently set up automated alerts. smAsho's got a lot of stuff coming its way. And we actually did our first tsunami alert yesterday as the show premiered. So as our Daily Space Weather show premiered yesterday on YouTube, we actually received an alert, and our patrons would have received that tsunami alert before anybody else. The earthquake that caused it just disappeared off the list. It was downgraded to a 6.9 from a 7.1 near Vanuatu, somewhere around this area. And I don't think it actually produced any tsunamis, as we never saw any additional alerts on that. So that's another thing coming soon to smAsho.com. Our patrons already have this benefit. And I think the largest quake of the past 24 was over a 6 magnitude. There's a 5.9 at the South Sandwich Islands region. So not a lot of significant quakes here to really report on in the past 24. Seismicity has chilled out a little bit. So this is an image here of Nishinoshima, the volcanic island, and quite a big caldera to island ratio, isn't it? Anyway, let's check out volcanodiscovery.com. That's a view of Nishinoshima, Karimsky, erupting on the Kamchatka Peninsula and exploding, indeed, 8,000-foot ash plume produced by it over Kamchatka. Shivaluch on the same peninsula, a little higher level of activity there, 15,000-foot ash plume. Flight level 100, a 10,000-foot ash plume over Paramushir Island from Mount Abiko. Nishinoshima. After 7 months, the Japan Coast Guard did a new flight observation. Images depict an impressive view of the volcanic island from the air, including detailed shot of the crater that we showed you just a minute ago. Anyway, activity there is explosive in nature. It's producing a 6,300-foot plume of volcanic ash. Suwanosejima also erupting, flight level 080. Over that, Luitolo in the Lesser Sunda Islands, 6,000-foot ash plume. Semeru, 14,000-foot ash plume over East Java as it explodes. Fuego exploding, producing a 15,000-foot ash plume over Guatemala. Revenador in Ecuador. Some effusive explosive eruptions being reported here by Instituto Geofísico. Volcanian-style eruptions. Explosions from the summit crater, accompanied by a 14,000-foot plume of volcanic ash. Also a lava flow on the northeast flank. Also Sabancaya producing a 25,000-foot plume of volcanic ash over Peru. Please don't pole vault the caldera. Somebody who knows not to pole vault the caldera are our patrons. Thanks, patrons, for being the source of funding for all kinds of expansion of our operations. You've even funded the Rage Cam. Let us know if you've seen the Rage Cam or if you know what it is. We may have to feature it on a daily space weather video, but I somehow doubt it. Thanks again to our patrons, patreon.com/smAshomash, where we remind you not to pole vault the caldera. This public service message brought to you by smashomash.com. And make sure you check out our website. There's major changes there, including the Smash team. More about that in a later video. And if you'd like to pick up some great merch with this amazing imagery on it, this imagery of Steve Stimpak just killing it, about to attempt to pole vault a caldera, head to smashomash.org, which will redirect you here to smashomash.com, or just type in smashomash.com. You'll find links to that at the SMASHO merch link. Shout out to Smash staff for all her hard work. Give Smash staff a raise by picking up some merch or becoming a patron. Next to goes X-ray flux here over the past 3 days, showing only minor B-class intensifications. Nothing to write home about there. No strikes in the proton flux, no coronal mass ejections headed Earth's way. Ghost magnetometer showing a fairly tight range here over the past 24 hours. Fairly low highs and fairly high lows measured by the GOES 16. So here's the heliospheric current sheet polarity imagery. Keep in mind this data is about an hour old from when we made the video. And it looks like Earth has just snapped into a North Pole current sheet. So if you look at the latest image here, you can see this green area that is North Pole oriented current sheet area. This is South Pole oriented current sheet area shown in red. Here's a line of sight view of that same data. And you can see this blue line shifting around. We can expect to see that shift a lot more as we are forecasting an uptick in coronal holes over the next 60 days. So we've said it for the last few days here. You're going to watch it happen. The line of sight coronal hole plot is our best view of coronal holes. Let me just scroll that down a little bit so you can see the times. And you can see this well-defined coronal hole in the north region there ahead of that filament. And I'm talking about this area right here. This coronal hole, we should expect some geomagnetism from that in a day or two, I would have to say. Although no forecast from NOAA on that, so we'll probably be reporting on some intensifications in the solar wind density, then the speed when the density ticks down. We'll show you today's solar wind speed in a moment. The entire solar wind data set, in fact. Anyway, that's showing you the sun's B field in blue as well, and this is very important for solar cycle progression. as this is probably the best place to watch the solar polar field reversal cycles happen as they happen. So here we see the solar flare probability monitor much higher here, as we said earlier in the video. It's because of so many sunspot groups. So we're actually picking up one here. It looked to me like they were all beta class. So I've got beta class, beta class, beta class, and another beta class forming down here in the southeast. We'll show you high-res imagery of that to see if that's still a thing or if that's evaporated while we recorded the show. Global geomagnetism currently only at a KP1. KP index is a measurement of the planet's overall geomagnetism. Each bar here represents 3 hours. Let's look at the real-time solar wind. So we've recently seen a little intensification here in the solar wind density, not very much at all, not even making it to 6 protons per cubic centimeter. Current conditions are just under 6 protons per cubic centimeter. Current solar wind speed recently intensified a little bit to 362 kilometers per second. That's still a pretty weak solar wind. We did also see the BT-BZ shift, this top pane here. BT is the total field, BZ is the polar contribution. So currently we've got a BZ of -4. That's a little bit more geoaffective than if we were at a BZ of 0. Also, we see a shift in the plasma temperature here, an indication that these are some pretty legit signals. Let's take a look at the geospace. And here's what is it called again? I forget. The Geospace Magnetosphere movie. Had a little bit of a senior moment there, folks. You're looking at the space weather modeling framework here in nanopascals, out to about a dozen Earth diameters. And you'll see a little intensification here of the magnetohydrodynamic pressure. That's that increase in the solar wind speed and density over the past few hours. Next, ground magnetic perturbations. Changes to Earth's own B field. We showed you the sun's. Here are geospace delta B, changes to Earth's B field. And we'll just let that play through. It's like the last frame, 4 hours of data courtesy University of Michigan. And we show it daily on the daily space weather videos. If you want to see what was happening on a previous day in the past, I think we're at 3+ years now, go check our older videos. The daily space weather going back quite a while, not missing a day. I think missing 1 day over the past 3 years. Next, a diagram of the solar system. Here's where stuff is now. We'll advance this to 1 week. There's where things will be on the 26th, full moon falling on Sunday the 22nd. Continuing on with the star chart. Now we've headed to in-the-sky.org to show you the path the sun will take across the sky, and we've just seen the sun rise here in Lehigh Valley. We've also shaded in the galactic plane. Jupiter has just set, the sun has just rose. Anyway, there's your star chart. If you want to build your own, head to in-the-sky.org. Today's cosmology segment will be short and sweet, integrated into the daily space weather video. Hey, check it out. It's another Perseid. And guess what stars we're looking at here? Any ideas, folks? Those are Deneb and Altair, part of the summer triangle. 2 of the brighter stars in the entire sky. And you can see the oxygen spectra here, that green. That's oxygen emitting ultraviolet, well, visible light here in the upper atmosphere as this Perseid creates a bit of a light show here. It's the astronomy picture of the day at apod.nasa.gov. Today's random number is 48. It's a quasar, B0119 plus 115. And quasars are a specific type of active galactic nucleus. Back in the mid-90s, we didn't know what these things were or why they were so bright. They look like an ultra bright star, but turns out they're galaxies. So they tend to be at great distances. And just a little concept of what is up with quasars. If you're looking at a galaxy that is, perhaps it's shaped like this, right? But you're viewing it from the edge. It's going to look more like this, right? Because there's going to be this central bulge, kind of like this. And many galaxies have this shape when viewed edge on, like a cigar shape. And many galaxies have galactic jets that come out of the poles like this, perpendicular to the galactic plane. If you're viewing this galaxy from within this galactic jet, it may appear as a quasar, making it look much brighter, very bright in X-ray and gamma ray in some instances. So right now what we're looking at is the pan-stars. This is optical wavelength, and you can see there is a bit of a dual nature here. You can see this redder area, and that appears to be part of the same galaxy. So perhaps we're looking at a jet structure here where we're sort of looking down this jet, and maybe this is the other jet that's facing in the other direction. Not exactly sure on that. The Pan-STARRS includes multiple optical wavelengths. If you look at this in infrared, you can see one single heat signature from that, indicating that that other object is probably part of the same galaxy. And when we scroll up and look at the Galix, here it is in UV. You can see a nice UV signature there. And those are typically emitted from plasma structures. That quasar probably at quite a great distance. That's our astronomy random end quote object of the day. Entry number 48 at the Neil Gehrels Swift Bat X-ray Observatory, quasar B0119 plus 115. Another catchy name for an active galactic nucleus known as a quasar. By the way, we've got a cosmology forum at smashamash.com/forum. If you want to read about our mission, head to smashamash.com/forum/mission. And we'll let it scroll here quick as this, once again, this cosmology segment is integrated in the daily space weather video. Check our playlist for over 220 additional cosmology segments, youtube.com/smashamash/playlists. Continuing on to look at the electron flux around planet Earth. It can charge up satellites on the surface. We don't see any of that going on now. Everything green in terms of satellite charging hazards. Here's the 1-year chart of the relativistic electrons measured at the F ionosphere layer at about 300 kilometers of altitude by the GOES 16. Here's a 3-day chart, and we didn't quite reach into warning levels yesterday. We saw a little lower levels than expected. And with these coronal hole, these little diffuse coronal hole wind streams coming in, we can't expect to see this to get into warning levels today. NOAA tends to agree that we're going to see flat or maybe even a little lower levels today. The green boxes are the forecast. The yellow diamonds are the observation. Here's a diagram of Earth Van Allen belts. And here's the total electron content forecast showing you the full air column, electron density therein. A little bit of chaos happening there over the Central Pacific. Otherwise, things looking pretty normal on the total electron content forecast. Next, we're going to show you the F ionosphere layer located at 300 kilometers of altitude, as we said. Feel free to pause this diagram to understand the layers of the atmosphere, electromagnetic penetration, temperature of the thermosphere, and atmospheric molecular concentrations. Here is the F ionosphere layer in megahertz. And it's the full day of data. Each blob here represents 1 megahertz, 1 million vibrations per second. And this data is courtesy of the Australian Government Bureau of Meteorology. And we see some low-frequency anomalies happening once again here, more so than the high-frequency anomalies, it looks like. Here's the latest image. That's from 10:15 Universal Time. Here is the anomaly map. This is the departure from the 30-day norm in megahertz. And you can see quite a few anomalies here, like centered on the South Atlantic anomaly. So the South Atlantic anomaly is no longer over here, folks. It's moved actually somewhere around here. It's right in the middle of the South American continent. And you can get great insight into where that is just by looking at this map. You can see delineation lines between low and high frequency anomalies right where the South Atlantic anomaly is, right very close to this area right here. Anyway, that's the ionosphere. Here's the current image from 10:15 Universal Time. There's the anomaly map from 10:15 Universal Time. Not looking totally out of the ordinary there. So once again, a fantastic meteorology segment. Make sure you check that out. There's a playlist for it, youtube.com/smashamash/playlists. And here come our bonus features in the form of ground-based solar observatory data. So once again, we're looking at the Lermonth, Australia ground-based solar observatory. And look at all the filaments. We've got filaments all over the Earth-facing portion of the solar disk. One over here, here. Filaments everywhere. Filaments everywhere. It's tempting me to turn the coronal mass ejection watch into a warning. The likelihood is getting very high, over 90% now, and we're going to have to develop a mathematical system for our CME watches in the future. Here comes some more imagery, and I don't know what's going on with the NASA GOES 16 SUVI imagery. That is there's clearly something going on with that. That is absolutely not what is happening. Let's just bring up the 284 angstroms as we never view this on the SDO. It's a wavelength that doesn't exist on the SDO. It's only on the GOES 16 and some other things, I think. But anyway, that is legit imagery there, complete with time and date stamps. Continuing on, here is the latest intensity gram. We're going to show you all these ombre. So you can see there's an alpha class group right there. There's a beta class group, as I see two ombre, most likely of opposite polarity. Coming over here to sunspot 2858, this has actually grown since this morning. So there's 2858, that's beta class. And as that moves toward the limb, the likelihood of solar flares goes up. We also saw some ombre down here, and these have now evaporated. So at least 3 different sunspot groups there, it looks like to me. And indeed, you can see these groups here. So yeah, at least 3 sunspot groups currently on the Earth-facing solar disk. Coronal mass ejection watch just this side of a warning. Here's some additional imagery for you. It's the northwestern limb, as well as a great view of this centrally located sunspot 2858 there. Spectacular imagery from the Solar Dynamics Observatory in 171 angstroms, my favorite wavelength. And here's some additionals. This is 94 angstroms, a different ionized iron emission spectra. This is all UV light, folks. It's all part of the ultraviolet spectrum used to view the chromosphere. We call it the chromosphere. It's colored. Yes, there are bands, spectral bands, as well as Fraunhofer absorption lines in there. Great view there in 94 angstroms. We've also got 131 angstroms. You can see those B-class flaring intensifications there in great detail at 94 angstroms. Here's 131. The other wavelength at the SDO that takes 10 images per minute instead of only 2, like 94 angstroms. So 94 and 131 are the highest temporal resolution that we get on the Solar Dynamics Observatory. They're specifically designed to observe solar flare activity. So we'll close things out here with a couple solar full disk views. This is 211 angstroms and 193 because, well, we've got coronal holes both around the equator and stretching down from the North Pole. Great view of these filaments in the northeast as well. And we'll close out today's daily space weather at 304 and 171 angstroms. So there's the fantastic imagery here, once again from the Solar Dynamics Observatory. And if you want to see some more spectacular imagery, watch our previous videos. Yesterday featured some extreme close-ups of those filaments before they started to, frankly, come in our direction. Anyway, thanks for tuning in, everybody. Remember to press like and subscribe. Tell your friends, foes, science noobs, and science pros about the channel. Press share. And we'll see you next time. May that solar wind be at your back.